element. So we want to look at the group 1 elements. What are the members of the group 1? Of course, are you aware that the group 1 elements are all metals? Are you aware? They are all, except what? No exception. Hydrogen is not in group 1. Hydrogen is not in group 1. It is studied, listen, you study hydrogen as a separate element in chemistry. It's not studied with any group. So if you have been taught that hydrogen is in group 1, then know that it only exists in your brain. You are the one that knows it, that one alone. So hydrogen is an element that can be studied. You can study it. You can try to compare it with group 1. Compare it mainly with group 17. It resembles group 17 element more than it resembles group 1. Okay, so if we should place hydrogen in any group, it should be in group what? 17. But a standard textbook will always place hydrogen separate on top. Okay, it's normally placed separate on top of the periodic table, showing that it doesn't belong to any group. Thank you. So we're going to move straight to the chemistry of the group 1 element. Who can tell me the group 1 name, the name of group 1 element? Alkaline what? Metals. Listen carefully. Why are they called alkali metals? What are they? Why are they called alkali metals? Why? Why are they called alkali metals? Somebody said they are reactive. It's not because they are reactive. Yes, they form alkalis. Is it right? That's just a simple way of expressing that word. They form what? Alkalis. And what are alkalis? What are alkalis? What are alkalis? Of course, there are classes of alkalis. What are alkali? An alkali is what? A base that exhibits high solubility in water. A base that does what? Exhibits high solubility in water. What does this mean? If you put that base in water, it will do what? Dissolve readily. Okay? So if you put large amounts of that base in water, it's going to dissolve. That's what I mean by saying that an alkali is what? A base that exhibits what? High solubility in water. High solubility in water. That's an alkali. A base that exhibits what? Exhibits high solubility in water. Remember, solubility is not an inherent property. You know what I mean by inherent? What it has inside it. It's a character that it will show when it comes in contact with what? Something, right? A solvent. So that's why I use the word exhibit. It is not a good expression to say something has high solubility. It's not a good expression. Because when you say something has something, it means it has it what? Inside. But you can say it shows, right? Good. So as a scientist, before you talk, think of what you are saying. You must be constructively correct, not just point. You have to be very careful what you say. So now, we have oxide alkalis. Oxide alkalis. Some oxides are alkalis. You have oxide alkalis. Tell me oxide alkalis. What are the oxide alkalis? Lithium oxide. Lithium what? Oxide. These ones are, let's look up. These ones are strong. Strong oxide alkalis. Sodium oxide. Potassium oxide. Potassium what? lithium oxide, sodium oxide, potassium oxide, what again? Rubidium oxide, then what again? Cesium oxide. What is the formula for this one? Li2O. What about this one? Na2O. What about this one? K2O. What about this one? RB2O. What about this one? CS2O. Lithium oxide, sodium oxide, potassium oxide, rubidium oxide, cesium oxide. All these are oxides and they are what? Alkalis. They are alkalis. They are strong. What does the term strong mean? What does the term that strong mean? That one is talking about degree of dissociation in water. Degree of what? How they are going to ionize? I've changed my mind because of the noise you made that time. Okay, now let's proceed. Lithium oxide, sodium oxide, potassium oxide, rubidium oxide, cesium oxide. All these are oxides and the alkalis. Remember, when we say something is an alkali, what comes into your mind? A base that does what? Exhibits high solubility in what? Thank you. Don't forget that. A base that exhibits high solubility in what? Water. Once something can dissolve, that is, once a large quantity of a compound can dissolve in water, then that compound, and that compound is a base, then it will be an alkali. It will be what? It will be what? Now, look up. Ammonia, is it an alkali? Is ammonia an alkali? Ammonia is an alkali. Is it a base? Is ammonia a base? Yes, ammonia is a base. Ammonia is a base. Then, since ammonia is a base, of course, what makes ammonia a base is the lone pair in it. Does ammonia have a lone pair? Yes. How many lone pair? One, right? Yes. It is the lone pair that makes it what? A base. The lone pair that makes it a base. So ammonia is a base. Then the question is, since ammonia is a base, let's see whether it is an alkali. Ammonia, does ammonia dissolve in water? Is it very soluble in water? Yes. Yes. It dissolves very well in water. It exhibits high solubility in water. So will it be an alkali? Yes. Ammonia is an alkali, but a weak one, is it right? Ammonia is a weak alkali. It's a weak alkali. It's a weak alkali. So you can see all these things, they are alkalis. Let me also give you this so that when you're talking about alkali, you should know an alkali can be an oxide. It could be a salt. It could also be what? A hydroxide. Is it right? So we have strong hydroxide alkalis. These ones are hydroxide. So that you can now understand why the group 1 metals are called alkali metals. Now, what are strong hydroxide alkalis? You have lithium hydroxide. Lithium hydroxide, what's the formula? LiOH. You have what again? Sodium hydroxide. What is the formula? NaOH. Another one, potassium hydroxide. What is the formula? KOH. Another one, rubidium hydroxide. Rubidium hydroxide. What is the formula? RBOH. Finally, you have cesium hydroxide. Cesium hydroxide, which is what? CSOH. You see, now that's on that. Do you notice that the oxides and the hydroxides of the group 1 element are alkalis? Do you notice that? You can see that most of their compounds are what? Alkalis. That is the reason they are called what? Alkalis. So that's why we say that the group 1 elements are called alkalis, because they form what? They form what? They form what? They form alkalis. They form alkalis. They form alkalis when they react with certain elements. Like when sodium reacts with oxygen, does it form alkali? If sodium reacts with oxygen, does it form an alkali? What is the alkali? If sodium reacts with oxygen, will it form something? What does it form? Sodium oxide, right? Is sodium oxide an alkali? Then that's why sodium is called what? Alkali metal. A metal that forms what? Alkali. A metal that forms alkali. That is just a simple meaning. I don't want to take you to the detailed dessin. You don't need that right now. Now, there are things we'll be talking about here. We're going to be talking about. I've not also finished this. Also, look at these ones. You have also carbonate alkalis. Carbonate what? Strong carbonate alkalis. Carbonate alkalis are salts. They are what? These ones are salt, but they're alkalis. They are salts, but they're also alkalis. Some salts are alkalis. Are you aware? Something like this. What does this represent? Na2CO3. What does it represent? Sodium triacarbonate what? 4. Or simply sodium carbonate. Is it an alkali? Is it an alkali? Yes. Is it a salt? Yes. It's a salt, but also an alkali. Why is it called an alkali? Is it a base? Listen, does it show basic properties when it dissolves in water? Yes. Does it dissolve very well in water? Yes. It is an alkali. But it's a salt. I hope you know that. So take note of that. So we come now, of all these alkalis on the board, who can tell me the most important alkali in chemistry? Which one is the most important alkali? Almost a lot of sectors, industries make use of it. Sodium hydroxide, most important alkali, is used for several purposes. And there is also another thing you need to know here. Before I will proceed, I would like you to know the meaning of which of them here. Of course, you know, virtually these hydroxide alkalis are deliquescent. Are what? Deliquescent. You know the meaning of deliquescent? Yes. What is deliquescent? You think you know? You think you know the meaning? You think you know the meaning? Yes. Okay, what is deliquescent? It absorbs what? Okay. So give me reason. Give me what will make something deliquescent. You see, let me tell you something. For you to be able, I keep telling you this, for you to be able to answer JAMB question in a glance, just look at question and know the answer. You must have good understanding. you must go back to those things you know and know them very, very well. Now, let me help you with this. You have this, you have this. You have this word, this and this. What is the meaning of hygroscopy? This word has to do with what? Relationship with what? Moisture in the air. That is this, right? So this is this. This is this. But this is not this. How me? Okay, so I want you to know the meaning of hygroscopic compound before we proceed. Or maybe, yes, let's look at the meaning of hygroscopic compound. So, quickly write hygroscopic compound. Hygroscopic compound. Be fast, be fast. Remember, when you are defining something, your definition should carry the main features of that thing. Something that somebody will look at, the person can be able to use it to answer questions. What is a hygroscopic compound? Okay, right. A hygroscopic compound is a solid or a liquid. A hygroscopic compound is a solid or what? A liquid. A hygroscopic compound is a solid or what? Liquid. Are you there? Yes, that attracts. Are you there? Yes. I repeat, a hygroscopic compound is what? Solid or what? A liquid. Can you see that now? It could be a solid, it could be what? A liquid. That attract what? That attracts little moisture. That attract little moisture or water vapor. That attract little moisture or water vapor. Are you there? From the surrounding air. From the what? Surrounding air. Air around it. From the surrounding air. From the what? And still remain in the original physical state. And still remain in the what? Original physical state. And still remain in the what? Original physical state. So what do you notice? That the thing will attract some moisture, water vapor, right? But it will still remain in the what? Which means if it's a solid, it will still remain what? If it's a liquid, it will still remain. So that is when you say something is hygroscopic. Now look at this. There is an acid called tetrodotoxylsulfuric acid. Do you know about it? Yes. Tetrodotoxylsulfuric acid. Is it a liquid or not a liquid? Look up. Dry tetrodotoxylsulfuric acid. Or you can say anhydrous. Anhydrous means the one that doesn't contain what? Anhydrous tetrodotoxylsulfuric acid. Tetrodotoxylsulfuric acid. Is it hygroscopic? Very hygroscopic. Is what? This acid, the hydrous one. How many of you have seen pure tetrodotoxylsulfuric acid? Have you seen it before? I don't think you have seen pure one. What you have seen is not pure one. What you have seen is a commercial one. The pure one normally look like engine oil. Very thick, like oil. How do you mean? That one is very, very dangerous. If it comes in contact with your skin, it will dehydrate your skin, remove water in your skin. The reaction of the acid with the water in your skin generates thermal energy that burns your what? Skin. Okay, but first of all, what it does is to remove what? Dry your skin such that as it generates thermal energy, that thermal energy can handle what? Burn your skin. Okay? So it's very, very dangerous. You don't play with it. Okay? Now, what about glycerol? You know what is glycerol? Is glycerol hygroscopic? Do you know? You don't know. Now, why do you, right now that you have Harmattan, if you want to buy cream now, what kind of cream do you buy? Vaseline, right? Why do you go for Vaseline? You need something that will make your skin what? Moist. Right? Something that can attract moisture from the environment. That is the function of this thing in what? You know this is used for making cream. Do you know that? So why is it used for making cream? Because it is what? So when you rub it, it will be attracting moisture to your skin, making your skin what? Smooth and shiny. Are you there? So that is the reason for using it to make cream. It is what? Hygroscopic. Are you there? This one, is it a liquid or a solid? It's a liquid, right? This one is also what? A liquid. A viscous liquid. They're all hygroscopic. You also have some solid that are what? Hygroscopic. Like calcium oxide, right? Is a solid. But after absorbing moisture, it will still remain solid. The highest thing it can do is that it can become sticky. It can become what? Those that are solid. Not all of them can become sticky. Now, let me also ask you this. If you keep a plastic chair, you know, if you leave a plastic chair outside to the next morning, when you wake up in the morning, and then, listen, if you wake up in the morning to check that very seat, what will you notice? Huh? If you wake up in the morning and see that seat, touch it, will you feel moist? Yes. The seat will feel moist, right? Yes. Why will it feel moist? Because it has attracted what? Moisture from air. But will the seat change to liquid? No. It will still remain in the original state, right? Yes. Which means that it is what? Hygroscopic. It is hygroscopic. So one thing I want you to know about hygroscopic substance is that what? It remains in the original what? Viscous state. After gaining some what? Moisture. And where is it gaining the moisture? From the air what? Around it. From the air around it. Are you aware that water is present in air? Yes. In form of liquid or vapor? Vapor, right? Yes. It will attract it and convert that water to what? Liquid. For you to understand this better, if you bring out a cold bottle from freezer and keep it on table like this, after some minutes, what do you notice that will start happening? You see water droplets, right? Water be dropping down. Where is the water coming from? Do you know? Oh, it's coming from inside of the bottle. It is coming from the surroundings. If this thing now is cold, if I bring this thing out from a maybe freezer, see what happens. Because the water molecule inside here has lower pressure. How with me? Has what? It has lower pressure. Okay? It has lower energy. Lower kinetic energy. When water vapor, you know, as I'm carrying this now, do you think air is touching this thing? Yes. Are air molecules colliding with this? Yes. Now, when air molecules collide with this, the water vapor and air loses what? Energy. They lose their energy to this thing. Are with me? When they lose their energy, they don't have energy again to go back. So what would they do? They will stick. So as many vapor come, They keep sticking. When they become many, they'll start what? Dropping. Are you with me? So the water is not coming from inside. It's just this thing that is attracting what? Water. Are you with me? So that is it. It's not water from outside. From inside, it's just water from this. So that's exactly what a hygroscopic substance does. It attracts water from the air, condenses it, and does what? Condense it, turn into liquid, and then you see liquid on the surface of that thing. Okay? Pardon? Cold water? An absence of air. If you have cold water in absence of what? Container that does not, you don't have air around it, whether you are going to see water droplet, from where? There will be no water droplet. That's a nice idea. She said, assuming this thing is cold, this is like a cold bottle, and I keep it in an environment where there is no air, in a vacuum, is there going to be water droplet from this? The answer is no. It can never happen. Because the water dropping from this thing is just water from what? Air around it. Okay? So that is what is playing out. These are questions they ask in physics. They ask in physics too. So now let's look at deliquescent compounds. So put that one down too. But before okay, go on, put it. Pick up deliquescent compounds so that you know the true meaning. Pardon? It's frozen, yeah? It will see water droplet from where? When you bring it outside. Mm-hmm. Yes. You think where the water droplet is coming out when the thing is out, or when it's inside? Where is inside the fridge? The water droplet that is coming out. Where is water? Why will water be on something inside fridge? Except if that fridge is no longer working. The same thing if you open the fridge now. But that will happen if you open the fridge. Then that one will not be like ice particles, maybe deposited inside that are not melting. Okay, that one is like ice particle deposited. Okay, that like, for instance, if you go to a fridge now, you see some ice particles there. So after prolonged uninterruption, that's power interruption. So you see those ice particles will start melting. And so that one is just melting that is taking place. It's different from this one. Now, deliquescent. Okay, right. A deliquescent compound is a hygroscopic solid. A deliquescent compound is a hygroscopic solid. A deliquescent compound is what? A hygroscopic solid that can attract enough moisture. That can attract what? Enough moisture from the surrounding air. That can attract enough moisture from the surrounding air. That can attract enough moisture from the what? Surrounding air. Are you there? And turns into a liquid solution. And turns into a liquid solution. And turns into what? A liquid solution. And turns into what? So what can you see about hygroscopic and deliquescent now? Hygroscopic, are they deliquescent? Or deliquescent, are they hygroscopic? The liquescent are what? Hygroscopic. And they must be what? In which state? Remember, hygroscopic can be a liquid, it can be what? But the liquescent must be. Why must it be a solid? You must know the original meaning of the word deliquesce. If you go to your dictionary and search for this word deliquesce, is a verb. What does deliquesce mean? It means a solid to turn into liquid. A solid to turn into what? Liquid. But you should also know that you have this word melting. Do you know that? Melting also means a solid to turn into. What is now the difference between the two of them? This one is solid turning into liquid, deliquescing. Melting is also a solid to turn into liquid. Okay? So what is not different between two of them? Agent. What will cause it is the difference. This one we need what? Thermal energy around. But this one we need what? It will absorb water vapor from air and dissolve in that water to form what? A liquid. So this word and this word means to turn into liquid. Is that right? A solid turning into liquid. That's the meaning of this. But it depends on what is causing the solid to turn into liquid. If it's thermal energy that is causing the solid to turn into liquid, then you say that the process is what? But if it is water vapor from air that is dissolving the solid to liquid, then you say it is what? Deliquescing. Deliquesce is the verb. Deliquescing is the action. Now, it doesn't end there because they can ask you one simple question. What physical property should a deliquescent compound possess? What physical property should a deliquescent compound possess? It's very important that you must know this. It's not only knowing that the deliquescent compound absorb moisture and dissolve in it to form liquid. When they ask you a simple question, you fail. So, for you to understand what will make something deliquescent, I want you to think about this. Think with me. If I keep something now, look up. First thing you must know is this. Everything has moisture in it. I hope you know the difference between moisture, water, steam, or water and so on, ice. You know these things are water. Are you there? But they are different. They are used in different ways. Moisture has to do with what? What does moisture mean? Water content of something. When water is contained where it's not supposed to be, when water is found as a free impurity in a substance, then it is called what? Moisture. So do you now see why we call water in air moisture? Because it's present in what? Air. But if you go to a stream now, will you call a stream moisture? Because it's in its own territory, right? But when you find water in another man's territory, then you call it what? Moisture. You need to understand the meaning of all these things so that you don't use them together to confuse the other ones. Then what is this one? When you hear this one refers to liquid state, is it right? This one is what? Vapor state. Are you there? Why this one is what? Solid state. Solid state is this one. But all water. Now, I want you to know this. Every substance has moisture in it. As you are now, do you have moisture in you? Yes, everything. Even this thing you see now, you don't have moisture. Everything. This your seat has moisture. Everything around you here has what? Moisture. Everything. Now, I want you to see something. Look up. I have small moisture here. I have moisture here that the energy, the pressure is weak. Pressure is small. Pressure is what? Which means it doesn't have enough force, energy to break out. Is it right? Now, I have air around. And the air around has a lot of what? Moisture. That has so many what? Pressure. High pressure. Now, what do you think? Think about this. If I have pressure here, now for you to understand it, let me show you what you need to know. As we are now, Do you think air is coming in here? Yes. Air, is it also going out? Yes. Now, listen. Assuming air outside has higher pressure than the air inside, which one will come in more? I want you to get this now. We have air inside here and outside, right? Yes. The one outside are coming in, the one inside are also going out. If the air inside here has greater pressure than the one outside, which one will come in and which one will go out? The one outside will go out, right? Yes. So the one outside will go outside to meet one outside, two of us. The one inside will go out to meet the one what? Outside. Because the one inside has greater pressure. What if the one outside has greater pressure? It will come inside, right? Yes. Now listen. If the water vapor in air has greater pressure than water inside here, who will go and meet the rest? The one here will come in to meet this one, right? If the water vapor in air has greater pressure than the water here, that means the one here will do what? Come here to meet this one, right? So which means for a compound to be deliquescent or hygroscopic, it must have low vapor pressure. So note down physical properties that make a solid deliquescent. Physical properties that make a solid deliquescent. You need to understand science. Physical properties that make a solid what? Deliquescent. They have not asked that question before. Expect it any moment. Physical properties that do what? Make what? A solid deliquescent. Number one is what? Is it high vapor pressure or low vapor pressure? Is it low vapor pressure? Write it down. Low vapor pressure is correct. So class, what do you think that the low vapor pressure will do? It will make what? Moisture in air to come in, right? To come in. Then, listen. Remember, you can keep your chair outside, and that chair will not turn into liquid. Why? Because it's not soluble in what? Water. Assuming water comes in contact with what it can dissolve, is it going to dissolve that thing? So what is the next property that will make that solid turn into liquid? High solubility in what? Water. High solubility in water. High solubility in water. High solubility in water. So you can see, if a compound is deliquescent, it means it has what? It has low vapor pressure. And again, it is very soluble in air. If these two conditions, these properties are absent, then count that compound out to be what? Deliquescent. Now, you can think of any deliquescent